Assalamu alaikum. I'm Rashid, an engineering student from Nairobi campus, and I would like to show you how to determine median, mean, standard deviation, and the value of constants in continuous random variable. So given a continuous random variable of x has a probability density function defined by fx equals to constant k multiplied by exponential raised to power half x. So we have been asked to determine the constant for that probability density function for x. So determining the value of k is the first step for that question. But the values of x are greater than 0, meaning are 0 and above, meaning 0 to infinity. So the limits for that x is from 0, and we don't know where is the maximum limit, meaning the maximum limit is supposed to be infinity. So how do we do with exponential function? Now, what to do is that we know that taking this is the solution for Roman 1. So taking the integrals of fx, so from 0 to infinity, the total probability normally equals to 1. So from 0 to where is infinity, the total probability normally is 1. Even when you add, the total probability becomes 1 from 0 to infinity for that function. So meaning integrating from 0 to infinity for that function k equals to e raised to power half x. Therefore, this integrals just equals to 1. That's what you have to assume. Sum integration meaning adding from 0 to 8, and when you add, the total probability is always 1. It will never be more than 1. Now let's integrate. When integrating constants, you take them out. Take constant k out and remain with 0 raised to power 8 e raised to power half x, then equate it to 1. Since k we don't want it here, just take it there by dividing both sides. So we'll take it later. Now, how do we integrate exponential function? So integrating exponential function, given a function e raised to power x, for you to integrate this one, you just first take the function as it is, then you divide by the derivative of power. You differentiate the power. What is the derivative of x? It's just 1 multiplied by 1, which is 1. Then x 1 minus 1, the power it will be 0. X power 0 is 1. 1 times 1 is just the derivative of x, it becomes 1. Now let's come and apply that concept here. So getting the derivative of this one, it should be just the function which is e raised to power half x divided by the derivative of a half x. This is the power. So 1 multiplied by half is a half, minus 1 to be 0. Any number raised to power 0 is 1. 1 multiplied by a half is just a half. So we divide by the derivative of that power, which is a half. Then the limits, so you have to plus constant c, the limits of 0 to infinity of 1 over k. It is mathematical correct for we to divide by k. Therefore, now what to know there? I'm sorry, my viewers, that the function was raised to power half. So I'm sorry. The exponential function was raised to power half. So I'm sorry for that. So meaning it's just a small change. Therefore, this should be raised to power half. This one to be raised to power half. Just then we divide it by negative a half, and this one should be raised to power half. So I'm sorry for that. Therefore, we can conclude that e raised to power half x is just, you can just write it as 1 over e raised to power a half x, then multiply by a half x. So it will be minus a half e raised to power a half x, then plus c for limits of 0 to infinity, which equals to 1 over k. So what to know here is just limits. What happens to this function? When you substitute the limit to be infinite, now what is happening to this function? What to apply here is just limits. You know, infinity is not, you don't know the value, it's not a value, but a very large, it does represent a very huge number. Now, when you substitute x with infinity, what is happening to this function? That is what you have to ask yourself. And this is a topic on limits. So just follow up with my videos and I'll talk about limits. What is happening to this? Let me just simply or briefly explain to you how to obtain the limits of this function. Now when x approaches infinity, now x is approaching infinity. These are the value of x from 0 to infinity. Now when it approaches to infinity, therefore a half multiplied by infinity is just infinity. So e raised to power infinity is just, that number is very large, we just say that is infinity. Then when we multiply by negative a half, it will be just negative infinity. So what happened now when 1 we divide by infinity? What is the result? Let's come here and show you something. What is 1? Let's assume that we are approaching infinity. What is 1 over e? This is very small value, so you can ignore it in limits. So it's just e raised to power 10. What is the result? Just say 1 all over shift exponential raised to power what? Raised to power. So exponential, exponential is already raised to power. You can see it here is already raised to power, so there's no need for you to raise to power. So you just write power 10. No, I'm wrong. I'm wrong there. So let's just take 1 over, just say 1 over the exponential. So you have to shift exponential. So raised to power 10. That no, that is a syntax error because exponential is already raised to power x, but what you have to do, just take 1 all over, you shift exponential, since just clear 1 over shift exponential raised to power what? Raised to power 10. This is just 4.5 times 10 raised to power negative 5, meaning 0.0 something. Now, what is happening when this is approaching infinity? Now, let's take 1 over e raised to power 100. 1 over exponential, shift exponential, power 100. What is happening? So the value keeps on, this is 3.7 times 10 raised to power negative 44. Negative 44 is almost 0.00 something. Now, we can say this function is approaching to 0.00. You can't write this one is 0.00 something. That is almost 0. Since this is almost 0, we can conclude that the limits of such a function when x, when we are being given a such a function and we are being asked to get the limits as x approaches to infinity, the result is just 0, then plus constant, then we have to minus, we have to substitute with 0 here. Just, it will be just, it is just So just take negative. This negative is a constant also. We will multiply it later, but this negative a half is not, just write it outside here. So negative a half, because it's not concerned in these limits. So we just take negative a half multiplied by what is here. So then, what is happening when 1 over e raised to the power half x approaches 0? Now is approaching 0. What is happening? When this approaches 0, the result of exponential of 0 is just 1. So exponential, just shift, exponential raised to the power 0 is just 1. So the result of that, it will be just 1. So minus minus 1. Equals to 1 over k. So therefore, minus a half here multiplied by this one is just 0, and here also we have to multiply by minus a half. Minus a half multiplied by that just 0, and multiplied by c. Here also we had to add c. Therefore, constant c and c normally cancel out. When you add c there, the constant out is you are minusing c. Therefore, it just equals to minus a half equals to 1 over k. Therefore, k just divide by this, then divide by, then multiply by k to be minus k a half k multiplied by half is just equals to 1. Divide by half minus a half to be k equals to 1 multiplied by the reciprocal. Multiplied by reciprocal of minus a half, which is 2 over 1. So multiplied by the reciprocal, it will be just like that. Therefore, we can conclude that our k equals to -2. That is our constant. So far we are done with constant. We have our constant being -2. So come and rewrite this function of x again. Now represent the value of k in your function, which is just -2 e raised to the power minus a half of x. That is the function now of x. But what if they are asking for mean? Getting mean is written as like this means mean. Also, this means mean. But in this random variables in probability function, we write a mean in like this one. So ex. Now, how do we get ex? Ex, we normally take the function of x, then we multiply by x. But after integrating from the limits, so limits of 0 to infinity in terms of x. So getting mean, we just integrate the function of x, we multiply it by x, then from the limits, then we substitute the limits. So integrating this function, we just get mean. When we integrate this one, we just get mean. So mean, therefore our mean ex, it's just the integral of 0 to infinity of -2e raised to the power minus a half x, then we multiply it by what? By x dx. When you multiply that function by x, just ex equals to the integral of e to infinity minus x e raised to the power a half x dx. I think we are all together up to that point. So what you have to ask yourself, how do we differentiate this function? How can we differentiate that function? So for we to differentiate this function, we have to apply partial differentiation. So partial differentiation states that for n function for n function of v dv, for n function v dv, therefore the integral for this function, the integral for that function is just we take the product of v times u. This is u, I'm sorry. V du, we just take v multiplied by u. Then we minus the integral now of what? U dv. It's simple to understand it since you just say for n function of v du, it's just you take v multiplied by u. After taking v multiplied by u, which v multiplied by u, you start from u dv. We already have v du, so we just take v multiplied by u, then so we just take v multiplied by u, then further differentiate now u dv. Now let's apply this partial differentiation formula. Therefore, you have to set, you have to set your v to be something and also your du to be something. This now, let me give you the secret of differentiating such a function with exponential. Applying this rule, you know that when you integrate or when you differentiate this one, differentiating is where a function keep on reducing. Now, for differentiation of exponential will never reduce. Mark my words, because the derivative of this function is just the function multiplied by the derivative of, so it will never reduce. It keeps on increasing. But when you have the function of x, here we have two functions, the product of two functions. When you have product of two functions, you have to apply partial derivative, partial integration. So you differentiate by parts. So you differentiate by parts by using this formula. Now let's apply this formula. Which will we substitute? How do you know that you substitute v or du? Which equation will you substitute with v and du? This is the secret I'm going to give you. So v meaning that getting, in our question we have v. We already have v. We can get v direct and we can get du direct from this equation. But how do we obtain u? How do we obtain dv? Since we have du, for we to get u, we have to integrate. But we are interested with the differentiation part first. So the differentiation part is you have to select a part which keep on, when you reduce it, the equation keep on reducing and lost. So you have to get lost one of the equation. And we see that this one is very difficult for you to get it lost, so you have to substitute it to be du, so that you just integrate it, because even if you differentiate it, it will never get lost, and we have to take one equation to get lost. Therefore, v you just substitute with x. Why? X, when you differentiate x, it get lost. Let's continue. What now? Getting dv, you have to differentiate. You all know that getting dv, you have to integrate, differentiate. When you differentiate this, you just multiply by 1, which is -1, then plus -1. When -1 to be x raised to 0, which is just 1. Then how do we get u now? We want u. There's u in our function. Getting u, we have to integrate. But integrating is just you take the function e raised to power -1/2 x, we divide by the derivative of power. Derivative of power is just -1/2. But when you divide by fraction, it's just multiply by the reciprocal, so it will be over 1. The multiply by 2 over 1. Since you are dividing by half, just multiply by the reciprocal, which it will be -2 over 1. Therefore, let's come and apply it in our formula, whereby the derivative of v du is just equals to what? Vu. So v multiplied by u, or uv. So vu is just take v multiplied by u, which is minus x multiplied by minus 2 e raised power a half x. Then minus the integral of v of u dv. Where is our u dv? U multiplied by dv. So just minus a half. This is just minus a half multiplied by minus 2 e raised power a half x. So let's simplify this function. So it will be minus and minus will be positive. So it will be 2x e raised power minus a half x minus it will be minus. So minus the integral of this function, it will be just now to minus, just minus and minus become positive. So it's just positive 2 e raised power minus a half x. Then ask yourself, how do we differentiate this one? So then what you have to do, just find the derivative of this one. Then you will then it will be just the derivative of that function. Therefore it will be just 2 e raised power minus a half of x minus the derivative of this one is just you take the function which is 2 e raised power minus a half x, then we divide by the derivative of power, which the derivative of power is just minus a half. Divide by minus a half is just multiply by the reciprocal. So then multiply by minus 2 over 1. That is minus 2 over 1. Therefore the derivative of that function is just 2 e raised power minus a half x minus 4 minus become plus 4. Minus plus 4 e raised power minus a half x. So 2 is plus 4 is just 6 e raised power minus a half x. So this, it will be the derivative of that function, which equals to our mean. So the limits were from 0 to what? Infinity. Now let's write this equation well. So mean is just 6 all over e raised power half x. So for we to remove the negative sign in indices, we are saying that just divide by that number raised to power positive. Then you have just converted it. When take it up, it becomes negative. Take it down, becomes positive. So the limits of 0 approaching 0 to infinity. Now what is happening to this function when now it approaches x approaches to infinity? So when the limit of 6 over this when approaches to infinity, e raised power, when this one approaches to infinity, when a half x approaches to infinity, a half, it's just this here it becomes infinity. A half times infinity is just infinity. E raised to power infinity. For limits 6 over e, or a number, this is is just constant. This keep on growing faster and faster as it approaches to infinity, and it becomes a very large number. When you divide a small number, this just remains 6, as this are going a million and million. And when you divide 6 with a large value like 1, when you divide 6 by a million and million of numbers, it just becomes 0. So when you substitute this with when you substitute this one with infinity, just the limits of 6 over e raised power half as x approaches infinity just becomes 0. So this will be 0. Then minus the limits of, and now what happens when the 0 e raised power nani approaches to infinity, e raised power half approaches to infinity. When this approaches to 0 now, this it will be a half times 0, which is 0. E raised power 0 is 1. So it's just 6. So when you divide by 1, then this one just 6. Therefore, mean of this just negative 6, something like that. So my dear brothers and sisters, just follow up with my video. Currently I'll explain how to determine the median and standard deviation in my next video. So welcome and enjoy my channel. For you to access or to get these uploads as I upload, just key in or tap the verification tab so that you can be verified each and every time I upload my videos. So I will be uploading these videos on mass concept and probability and other concepts each and every day. So for you to get my updates, just subscribe and press the notification tab, turn it on so that you can get access of this video each and every time I upload. So thank you very much. When you enjoy, I'm waiting for your comments. When you enjoy what I'm talking about and you benefit from it, I need your comments so that I can also be motivated and upload more and more video. So welcome to my channel. Welcome very much.